Good day everybody, we got a beautiful question. We are expected to integrate extend ln x over x positive 1 times x squared positive 1 times dx. Now foremost I would like to rewrite this as x over x positive 1 times x squared positive 1 times ln x times dx. And then I would like to consider x over x positive 1 times x squared positive 1, and then I would split them into partial fractions as follows. Cross multiply, you get x is equal to a times x squared positive 1 plus bx positive c times x positive 1. Now you make this term 0. So you take x is equal to negative 1, so that would mean you have negative 1, a of negative 1 would become positive 1, so therefore you have 2 times a is negative 1, so a is equal to negative 1 over 2. Next you take x to be equal to 0, this term will go away, you got 0 here, so you will have a c there, and then this term will become 0, x squared will become 0, so you have a there, this is going to be 0, but a is negative 1 over 2, therefore c is equal to 1 over 2. So you have got the values for a and c. Next you simply take x is equal to 1 over here, so that would give you 2 times a plus b plus c, and 1, 2, 1, a is negative 1 over 2, this will be negative 1, right? Positive b has to be obtained. The value of c is 1 over 2 times 2, so this is negative 1 plus 2 times b plus 1 is equal to 1, and this one gets cancelled, so 1 is equal to 2b, therefore b is equal to 1 over 2, right? So x, I'm going to use this, so therefore x divided by x positive 1 times x squared positive 1 is equal to a is negative 1 over 2 divided by x positive 1, and b is 1 over 2 times x, and c is also 1 over 2, right? A and c and b are 1 over 2 divided by x squared positive 1. So let me write this down. So therefore integral x over x positive 1 times x squared positive 1 times ln x times dx is equal to integral negative 1 over 2 divided by x positive 1 followed by positive 1 over 2 times x divided by x squared positive 1 positive 1 over 2 over x squared positive 1 times ln x times dx. I need to go to a new page, so I have rewritten all the terms that we have got thus far. Now the limits are 0 to 1, so that has to be placed. So having obtained this, we need to evaluate each of these integrals. Now I would like to begin the integration by this term. Now integral 0 to 1 ln x over x squared positive 1 times dx is referred to as the Catalan's constant. Of course there should be a negative sign, right? And this is represented as g. So the person who is responsible for discovering this constant goes by the name Eugene Charles Catalan, and the value of this g is 0.9159 approximately. So let me rewrite this. Integral 0 to 1 negative ln x over x squared positive 1 times dx is equal to g, but we need positive, so that would mean integral 0 to 1 ln x over x squared positive 1 times dx is equal to negative g. So if you were to take this as sum 2, I can rewrite 2 to be as negative 1 over 2 integral 0 to 1 ln x over x positive 1 times dx positive 1 over 2 times integral 0 to 1 x times ln x over x squared positive 1 times dx. Now in place of this I would be placing negative g. So this is g over 2 with a negative sign. So this is evaluated and it has the value 0.9159. Okay, so much so for that. Now we need to evaluate two of the integrals. We need to evaluate this, we need to evaluate this. So foremost what I wish to do is I would like to consider this one. Let me take this as I1 and I2. Consider I1 to be equal to integral 0 to 1 ln x over x positive 1 times dx. Now I would like to rewrite this as integral 0 to 1 ln x. Now if you were to take, say, y is equal to ln of x positive 1, and if you were to ask to differentiate this, dy over dx is going to be 1 over x positive 1, right? So is it okay if I can club these two terms and write them as d of ln of x positive 1? Do you agree with me? That means I am applying the differential operator to this. This would give me 1 over x positive 1, and since I am differentiating this, I can always rewrite this as dx over x positive 1, right? So this representation is going to produce me this, which is the required quantity of integration. So having mentioned that, what I would like to do is I would like to now integrate I1 is equal to 0 to 1 ln x times d of ln of x positive 1. Now I would like to use integration by parts. So let me take u to be as ln x, and let me take dv to be equal to d of ln of x positive 1, right? So I differentiate this. So du is equal to 1 over x times differential of x, that's dx. I integrate this. Integral of dv is v. Integral of this quantity is going to be ln of x positive 1. So we will utilize the integration by parts formula, which is uv negative integral v du. So by that formula, this is equal to, my u is ln x, my v is ln of x positive 1. The limits are 0 to 1, negative integral, my v is ln of x positive 1 times my du is dx over x, right? So we have to apply the limits. The limits are 0 to 1. Now if I were to apply the limits, this is going to give me 0, right? So I am left with negative integral 0 to 1 ln of x positive 1 over x times dx. This is what I've got. Now the question is, I will have to integrate this. Now for integrating this, I would like to use the Maclaurin's representation for ln of x positive 1. Now ln of x positive 1 is equal to sigma n is equal to 1 to infinity negative 1 raised to the power of n negative 1 divided by n times x raised to the power of n, where x is defined for the open interval negative 1 comma 1 closed interval. So for all values that are existing in this, I can very well use the representation as this. Now the limits are 0 to 1, right? So if you were to draw the number line, this is 0, this is 1, this is -1, and this covers everything between -1 to close to interval 1. So we can very well use this representation. So what I'm going to do is I'm going to rewrite this to be as negative integral 0 to 1. In place of ln x, I'm going to be utilizing sigma -1 raised to the power of n -1 divided by n times x raised to the power of n, and you have a quantity x here, place that, times dx. Fair enough. Okay, so now you can push this x to the numerator. That would give you negative integral 0 to 1 sigma -1 raised to the power of n -1 divided by n times x raised to the power of n -1 times dx. Okay, now the all important flip. Now I want to move this sigma outside, and it is only possible if the quantity inside are convergent and bounded. Now clearly this is convergent and bounded, and because of that I can move the sigma out. So I now have sigma n is equal to 1 to infinity, it's all 1 to infinity, and you have a negative sign, integral 0 to 1. In fact, I can place -1 raised to the power of n -1 divided by n, because this is integral with representation of, or I should say with respect to x, so I don't have to place them inside, and you got x raised to the power of n -1 times dx. Now this is a straightforward integration, so this is equal to negative integral, so -1 raised to the power of n -1 divided by n, that's for one part. Now if you were to integrate this, this is going to be x to the power of n -1 positive 1 divided by n -1 positive 1, and the limits are 0 to 1, right? So I can very well rewrite this as negative sigma -1 raised to the power of n -1 divided by n. Now -1 positive 1 goes away, you have x to the power of n divided by n with the limits are 0 to 1. Now n is a constant, you take it out, so you can rewrite this as negative sigma -1 raised to the power of n -1 divided by n squared. Limits are 1 to infinity, right? You can place the limits 1 to infinity, okay, and you got x to the power of n, the limits are 0 to 1. Now you apply the upper limit minus lower limit, so this is going to be negative sigma 1 to infinity -1 raised to the power of n -1 divided by n squared. You apply the upper limit 1, which is 1 per power n, negative 0 to the power of n, that's going to be 0. So you have negative sigma 1 to infinity -1 raised to the power of n -1 divided by n squared. So this is the quantity that you have got now. Now the question is, you will have to evaluate this quantity. Now for evaluating this, I'm going to utilize the popular Bessel's problem, which I have done it, and I will put the link, you can refer to that. So the proof is given, n is equal to 1 to infinity of 1 over n squared is equal to pi squared over 6. So this is the result we will be utilizing. Now let me just consider, now you have two components here, that means you have odd numbers and you have even numbers. So to evaluate that, I would like to consider first the even numbers. So consider all even numbers. Sigma n takes only even numbers. So if n takes only even numbers, then let me write this down here. So for all values, so first let me write the series. n is equal to 1 to infinity. So I'm going to write that n is equal to 1 to infinity. Let me place the negative sign here. So negative 1 raised to the power of n negative 1 divided by n squared. Now this, if you were to evaluate this, this is going to be equal to n is equal to 1, 1 minus 1, that's going to be 0 to the power there. So that will give you 1, that's 1 over 1 squared. So n is equal to 2 will give you a negative number. So negative 1 divided by n is equal to 2. So 2 squared, then n is equal to 3, that's going to be positive. So 3 squared, negative 1 over 4 squared, positive 1 over 5 squared, negative 1 over 6 squared, positive, etc. So this is the term that we are getting. Okay, now I need to evaluate this term. Now what I would do is, to begin with, I would like to consider 1 over, now I can actually rewrite this like this. So instead of saying consider, this is equal to 1 over 1 squared plus 1 over 3 squared plus 1 over 5 squared plus 1 over 7 squared plus etc. Right, minus 1 over 2 squared plus 1 over 4 squared plus 1 over 6 squared plus etc. So odd numbers, even numbers. What is this? This is equal to sigma 1 to infinity negative 1 raised to the power of n minus 1 divided by n squared. I am not placing the minus sign as yet. I will evaluate the odd terms. This is odd, and I will evaluate the even terms. Then I will perform the subtraction, and then I will take the value. Then I will use this value over here, and that would be the solution. Of course, I understand it's a little bit lengthier. So what I wish to do is, I would like to make a representation. So how do I make a representation for this? Now this entire quantity is equal to sigma 1 over 2n raised to the power of 2. N is equal to 1 to infinity. Right? Is it okay? Can I write it like this? N is equal to 1, I get 2 squared. N is equal to 2, I get 4 squared. N is equal to 3, I get 6 squared. N is equal to 4, I get 8 squared. I get the entire term. Right? Now this, let me show the outcome here. Now this is equal to, can I rewrite this as sigma 1 over 4 times n squared, which is equal to 1 over 4 times sigma 1 over n squared, which is nothing but 1 over 4 times, I know by Bessel's, sigma 1 to infinity 1 over n squared is pi squared over 6. So this is pi squared over 6, so this is equal to pi squared over 24. So that is the evaluation part for this quantity. So this is equal to negative pi squared over 24. Right? Simple as that. Now odd numbers. Now this is equal to, I'm going to give you the odd numbers. So how do I generate the odd numbers? Now we will have to actually generate the entire series for odd numbers, and then from that we will have to subtract. If I were to take this sigma 1 to infinity of 1 over n squared, n is equal to 1, I get 1 squared. N is equal to 2, I get 2 squared, 3 squared, 4 squared, 5 squared, etc. So on it goes. But from this I need to subtract all even numbers. So sigma 1 over 2n raised to the power of 2. Right? So if I were to subtract from this all the even number quantities, I would be left with all quantities. Right? So I know this value. What is this value? This value is pi squared over 6. I know this value. This value is pi squared over 24. So I need to evaluate this. So let me evaluate this particular quantity over here, because I don't want to flip to the next page. So you got pi squared over 6 negative pi squared over 24. I take the LCM as 24. This is 4 pi squared negative pi squared, which is equal to 3 pi squared over 24, which is equal to pi squared over 8. So this entire value gives me pi squared over 8. Now I need to place this pi squared over 8, right? So I am placing pi squared over 8. Now I need to evaluate this pi squared over 8 negative pi squared over 24. That would give me pi squared over 12. Okay, now what is this? This is sigma. Okay, this is sigma 1 to infinity negative 1 raised to the power n minus 1 divided by n squared. This is this value, but we need this value. So all these things is for your understanding. All these things for your understanding. So this is equal to negative, substitute the value pi squared over 12. Okay, so I have evaluated which one? This integral. Let me show you. This is the integral I have considered. So this integral I have considered and I have evaluated it, but that is not the end, right? So we have to take this pi squared over 12 and we have to substitute it in this a, right? We got to do that. So that one, because we have just evaluated this quantity. Consider, good thing I have written consider. So I've just evaluated this quantity. So if I were to take negative pi squared over 12 and substitute here this, so I know this value, I know this value, I need to integrate this value. We have this negative 1 over 2 integral 0 to 1 ln x over x positive 1 times dx plus 1 over 2 integral 0 to 1 x times ln x over x squared positive 1 times dx negative the Catalan constant divided by 2. Now this one I just showed you, integral 0 to 1 ln x over x positive 1 times dx is negative pi squared over 12. So if I were to take this as b, therefore b can be written as negative 1 over 2 negative pi squared over 12 positive 1 over 2 times integral 0 to 1 x times ln x over x squared positive 1 times dx negative g over 2. This is pi squared over 2 times 12 24 negative negative positive 1 over 2 integral 0 to 1 x times ln x over x squared positive 1 dx negative g over 2. I need to evaluate this. So let me consider integral 0 to 1 x times ln x over x squared positive 1 dx. Now let me take x squared is equal to u. So this is 2 times x dx is equal to du. So x dx is equal to du over 2. The limits don't get changed. They remain as it is. In place of x dx, I substitute du over 2. I place a 2 here. In place of x, x squared is equal to u. So x is equal to root of u. So this is going to be root of u divided by x squared is u positive 1. Now ln root of u is nothing but ln u raised to the power 1 over 2, which is equal to 1 over 2 times ln u. So by that, this can be rewritten as 1 over 2 times 1 over 2 limit 0 to 1 ln u du divided by u positive 1, which is equal to 1 over 4 times integral 0 to 1 ln u over u positive 1. Now this one we evaluated it to be as negative pi squared over 12. So this is negative pi squared over 12, which is negative pi squared over 48. Now take this value and put it in b, right? Again you can write, probably you can put it over here. So therefore I can rewrite c. This is my c. Probably I can take this to be a c. This is my c. So c is this entry, right? So pi squared over 24 plus 1 over 2. Now we have evaluated this, which is equal to this negative pi squared over 48 negative g over 2. So this is equal to pi squared over 24 negative pi squared over 96. Right, 4 2s are 2 times 8 16, 4 2s are 8, 96 negative g over 2. Right, this is what we have got. Now you can use the value of pi to be as 3.14, the value of g to be as 0.9159, and evaluate this entire component and place them in units. Okay, so this is the solution for this beautiful question. Please like, share and subscribe to our channel. Until we meet again, thank you.